Imagine a computer that runs at the speed of light, uses a fraction of the energy of today's devices, and generates virtually no heat. It sounds like science fiction, right? Well, scientists at New York University may have just taken a giant leap towards making this a reality with the discovery of a completely new class of material called gyromorphs. This isn't just an upgrade, it's a potential revolution in how we compute. For decades, we've been pushing the limits of what's possible with traditional electron-based computers, but we're hitting a wall. As components get smaller and faster, we face major challenges with heat, energy consumption, and the physical limitations of electrons. That's why some of the brightest minds have been working on a radical alternative, light-based, or photonic, computers. Instead of pushing electrons through wires, these machines would use photons, particles of light, to process and transmit information. The benefits? Lightning-fast speeds and incredible energy efficiency. But there's been a huge roadblock. To build a reliable light-based computer, you need to control the flow of light on a microscopic chip with incredible precision. A major hurdle has been finding a material that can effectively block stray light from all directions to prevent signal loss. Think of it like trying to have a quiet conversation in a room with terrible acoustics. The unwanted noise drowns out the message. Scientists have experimented with materials like quasicrystals, which have an ordered but non-repeating structure. But they came with a frustrating trade-off. They could either block light completely from only a few directions, or they could partially block light from all directions, but not completely. Neither was good enough for the high-fidelity world of computing, and that's where gyromorphs come in. Developed by a team at New York University, gyromorphs are a brand new class of material that uniquely combines the properties of both liquids and crystals. It sounds impossible, but here's the key. They have a liquid-like randomness up close, but from a distance, they form regular patterns. Lead researcher Stefano Martiniani uses a great analogy. Think of trees in a forest. Their positions seem random, but they're not completely random because they're all a certain distance from each other. It's this correlated disorder that gives gyromorphs their incredible power. This unique structure creates what's known as an isotropic bandgap. That's a fancy way of saying it can block light from any direction. This is the holy grail for photonic computing. With gyromorphs, we can finally create the perfect, quiet room for light signals on a chip, ensuring that information is transmitted with minimal loss. In fact, the university researchers have shown that gyromorphs outperform all other known structures, including quasicrystals, in their to block light from all angles. So, what does this mean for the future? Well, the most immediate and exciting application is in light-based computers. This discovery could pave the way for ultra-fast, energy-efficient data centers. Imagine the servers that power the internet running on a fraction of the electricity they currently consume. More powerful AI. Training and running complex artificial intelligence models requires immense computational power. Gyromorph-based computers could unlock new possibilities in AI development. Revolutionary consumer electronics. While it's still a way off, this technology could eventually find its way into our everyday devices, making them faster and more powerful than we can currently imagine. And the potential doesn't stop there. The unique properties of gyromorphs could also be used in things like highly reflective coatings and advanced optical technologies. We are still in the early days of this discovery, and there's a lot more research to be done before we see gyromorphs in our laptops. But what the team has done is open a door to a new frontier in materials science and computing. Gyromorphs are a testament to the power of thinking outside the box and combining seemingly incompatible ideas. They show us that sometimes the most revolutionary breakthroughs come from finding order in chaos. This is a story of innovation that could genuinely change the world. What do you think the future of computing will look like? Let us know in the comments below. Thanks for watching.